Hi everyone, I am Dr. K. Prabharan, Professor, Department of Mathematics, K.S.Rangasamy College of Technology, Tiruchendur, Tamil Nadu, India. Today we will see the topic vector calculus in the important area, the solenoidal and irrotational vector field. Before going the problem, I give a small introduction of solenoidal and irrotational problems. A vector calculus. A vector field assigns a vector to every point in space and is commonly used to represent physical quantities such as velocity, force, electric field, and fluid flow based on their divergence and curl properties. The vector fields are classified as a solenoidal and irrotational fields. A solenoidal vector field is one in which the divergence is zero, indicating that there are no sources or sinks within the field. An irrotational vector field is one in which the curl is zero, implying that the field has no rotational or swirling motion. These fields are conservative in nature and can be expressed as the gradient of a scalar potential function. The study of solenoidal and irrotational vector field play an important role in fluid mechanism and electromagnetism and engineering mathematics areas. So, what is the meaning of the solenoidal and irrotational vector field? The any divergence and curl, the F vector will become F1 into I vector plus F2 into J vector plus F3 into K vector, we assume. Be a vector point function, the divergence F vector is defined as the del dot F vector. So we know that del means dou by dou x into I vector plus dou by dou y into j vector plus dou by dou z into k vector. So we know that already the f vector means f1 I vector plus f2 j vector plus f3 k vectors. The just dot product dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z. The curl of f vector means just the del cross f vector. That's called our determinant of the matrices model. The I, j, k vector dou by dou x into dou by dou y into dou by dou z, our vector value of the given function f1, f2, f3. So now the irrotational means solenoidal and irrotational definition here I mention a vector f vector f1 I vector plus f2 j vector plus f3 k vector is said to be a solenoidal means if it is a divergence is zero. That is example, the magnetic field the B vector is solenoidal means del dot B vector value will become zero. So a vector is a irrotational means the f vector f1 I vector, f2 j vector, f3 k vector is said to be irrotational if its a curl is a zero. The example, electric field E vector due to stationary charges is irrotational, del cross E vector value will become zero. So let us see the some example problems. So that the vector f vector x plus 3y into I vector, y minus 3z into j vector plus x minus 2z k vector is a solenoidal. So we know that solenoidal means our divergence of the given f vector value will become zero, means the problem will satisfy the solenoidal condition. Therefore the divergence of f vector del dot f vector. So we know that already del means dou by dou x into I vector plus dou by dou y into j vector plus dou by dou z into k vector. Our problem of f vector x plus 3y into I vector plus y minus 3z into j vector plus x minus 2z into k vector. So just the partial derivative with respect to x for the first value, the dou by dou x into x plus 3y. The derivative with respect to x means the value will become 1. And second of dou by dou y, and derivative with respect to y minus 3z, that value will become the only 1. And third one derivative dou by dou z into x minus 2z, the derivative value will become the minus 2. So now we see that 1 plus 1 minus 2 equal to 0. The divergence of f vector value becomes 0. Therefore the given f vector is a solenoidal. So now the same ideas, we determine the some constant values. We are applying for here the solenoidal concept. See the second problem, find the a value such that the vector 3x minus 2y plus z into I vector plus 4x plus ay minus z into j vector plus x minus y plus 2z into k vector is a solenoidal. So we know that definitely the solenoidal means the satisfied divergence of f vector value will become 0. So we are applying the same concept here, the divergence of f vector into our problem 3x minus 2y plus z into I vector plus 4x plus 2y minus j vector x minus y plus 2z into k vector. So we see that the derivative of this problem, the derivative with respect to x means the first of the value is 3x minus 2y. The derivative of value only 3. And second one, the derivative of the with respect to y, the first of value 0 and second of value only a. And third one, the derivative with respect to z means here the value will become the 1. Therefore the a value taking the constant 3 plus 1 equal to 0, the value will become 4. Therefore the a value will become the minus 4. So now the third one, now see that the problem is a irrotational concept. So that the vector f vector 2xy into I vector plus x square into 2yz into j vector plus y square plus 1 into k vector is a irrotational. We prove that. So we know that irrotational means del cross f vector value will become the 0. So therefore the given problem will define our field f vector equal to the given problem 2xy into I vector plus x square into 2y into j vector plus y square plus 1 into k vector. Now the del cross f vector I vector j vector k vector dou by dou x dou by dou y dou by dou z. Now we know that our I vector value 2xy and j vector value x square plus 2yz and k vector value y square plus 1. Just the determine these matrices in derivative of partially. The I into the partial derivative, we know that dou by dou y into y square plus 1. The derivative with respect to y means we have the value 2y. And now we know that minus dou by dou z into x square plus 2yz. The derivative with respect to z, the first value will become 0 and second one we have the z variable, therefore the value 2y. So minus j into derivative of with respect to x dou by dou x into y square plus 1. Here there is no x variable, therefore the value will become 0. So minus dou by dou z into 2xy. Here the derivative, the partial derivative with respect to z, the value will become again here 0, here no z value. So now the k vector dou by dou x into x square plus 2yz. The derivative with respect to x value 2x only. So minus dou by dou y, the derivative with respect to y into 2xy. The value will become 2x. So now simplifying this value, I vector into the 2y minus 2y minus j vector into 0 minus 0 plus k vector into 2x minus 2x. We see that all the value positive, negative, 0, 2x minus 2x. We have the value will become 0. Therefore, the given f vector is a satisfying del cross f vector equal to 0. Therefore, the given f vector is a irrotational. Now the fourth problem here. Find the value of the constant a, b, c so that the vector f vector x plus 2y plus az into I vector plus bx minus 3y into j vector plus 4x plus 3cy plus 2z into k vector is irrotational. So we know that the irrotational concept applying here and determine the value of a, b, c, the constant value. The given problem clearly mentioned is a irrotational. This irrotational means del cross f vector equal to 0. Therefore, directly I apply here the irrotational concept I vector, j vector, k vector, dou by dou x, dou by dou y, dou by dou z into x plus 2y plus az, bx minus 3y minus z, 4x plus 3y plus 2z equal to 0. Again the derivative of this integration, the I into the partial derivative with respect to y. Here we see that 4x plus cy plus 2z, only we have the c. So minus dou by dou z means the value will become derivative of partially bx minus 3y minus z means minus 1. So minus j into the values determined here I vector into dou by dou x, and the value 4x plus cy plus 2z, the value will become only 4. So minus dou by dou z value x plus 2y plus az partial derivative, the value will become only minus a. So now the last one, the k vector value, the integration with partial derivative with respect to dou by dou x into bx minus 3y minus z, the value will become only b. Now the minus of dou by dou y x plus 2y plus az value is a minus 2 equal to 0. So now we see the value I vector c minus of minus 1 and minus j vector into 4 minus a plus k vector into b minus 2 equal to 0. So now equating this value c minus 1 into of minus 1 equal to 0 means c plus 1 equal to 0. The minus 4 minus a, that value will become again minus of 4 minus a plus b minus 2 equal to 0. So now equating this value, we will become the value, the c value become 1 and a value become 4 and b value equal to 2. So now I give the practice problem here, the two problem. Again we know that the concept of irrotational and solenoidal problems. So try to solve this problem, easily understand our solenoidal and irrotational concept of vector field. Thank you for watching my video.